Let's explore Git Filter Branch. This is a tool used for rewriting repository history at scale. Git Filter Branch is a powerful tool specifically designed for rewriting Git repository history. It rewrites commit history using custom filters and operates on entire branches at once. With Git Filter Branch, you can modify files, commit messages, and even authors. This tool is useful for removing sensitive data. Though it is considered a legacy tool, it is still very powerful. Let's discuss some common use cases for Git Filter Branch. First, removing sensitive data. You can purge passwords, application programming interface keys, or personal information that was accidentally committed to the repository history. Second, repository restructuring, where you can move files or directories to different locations while preserving their history, or extract a subdirectory into its own repository. Third, fixing author information, where you can correct author names and email addresses across the entire commit history to maintain consistent attribution. And fourth, cleaning large files, where you can remove large binary files or datasets that bloat repository size, making cloning and operations faster. The basic command structure for Git Filter Branch is Git Filter Branch, then options, followed by revision list options. A common example is Git Filter Branch with the environment filter option. In the environment filter option, and if condition checks for a specific email address, and if the condition is true, it exports a new email address. The head option at the end specifies the commits to filter. Now let's discuss some common filter types. First, the environment filter. It modifies commit metadata, such as author and committer information. Second, the tree filter. It modifies files in the working directory for each commit. Third, the index filter. It modifies staged files and it's faster than a tree filter. Fourth, the message filter. It rewrites commit messages. And fifth, the subdirectory filter. It extracts a subdirectory as root. Let's see an example of removing sensitive data using Git Filter Branch. Here, we use the index filter to remove a file containing sensitive data from all commits. The command is git filter branch force index filter, then git remove cached, ignore unmatch and the file name, then prune empty tag name filter cat and all. After running filter branch, force push to overwrite the remote history and ask collaborators to rebase their work. Let's explore an example of changing author information. We'll use the environment filter to modify author and committer information. The command is git filter branch environment filter. Inside the filter, and if condition checks for the old email address. If it matches, the script exports the new author email and the new author name. You can update both author and committer information in the same command by also checking and modifying git committer email and git committer name. Now let's consider extracting a subdirectory into its own repository while preserving its commit history. The command is git filter branch subdirectory filter the path to the subdirectory, prune empty and all. After running this command, the specified subdirectory becomes the new project root, and all commits that didn't affect this directory are removed. Let's talk about the performance considerations while using Git Filter Branch. Filter Branch can be extremely slow on large repositories. Each commit is checked out and rewritten, which is resource intensive. Memory usage can spike with large files, or many commits in temporary files can consume significant disk space. Git documentation recommends using Git Filter Repo instead of Filter Branch for better performance. Now let's discuss some optimization tips. Use index filter instead of tree filter when possible. Limit the range of commits with revision options. Use prune empty to remove commits that become empty, and run on a fresh clone with no local option. For very large repositories, consider using Git Filter Repo, which is up to 100 times faster than Filter Branch. Here are some best practices to keep in mind. Always create a backup of your repository before running Filter Branch. This operation rewrites history and cannot be easily undone. Inform all collaborators before rewriting history. They will need to rebase their work or reclone the repository after your changes. Run filter branch operations on a fresh clone first to verify the results before applying to your main repository. After running filter branch, carefully inspect the new history to ensure the desired changes were made correctly before pushing. Let's discuss some modern alternatives to Git filter branch. First, Git filter repo. This is a faster, more powerful alternative specifically designed to replace filter branch with better performance and usability. Second, BFG Repo Cleaner. It is optimized for removing unwanted data like large files or credentials from Git history, and it's much faster than filter branch. Third, Git Rebase Interactive Mode. This is for simpler history rewrites on smaller ranges of commits. Interactive rebase can be more straightforward. Here are the key takeaways. Filter branch is powerful but slow for rewriting Git history at scale. Use it for removing sensitive data, changing author information, or extracting subdirectories. Always back up your repository before running filter branch. Consider modern alternatives like Git Filter Repo for better performance. Rewriting history requires coordination with your team. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.